Okay, so we're just going to finish up our graphing, and with our graphing, we've graphed in vertex form, and now what we're going to do is we're going to use that vertex form to describe what's happening to our original graph. So our original graph, y equals x squared, it's really simple. It starts at 0, 0, and in fact, here, let's grab a new thing here. So y equals x squared, pretty simple. We have a vertex is 0, 0. Our slope is going to be 1, 3, 5, 7. So up 1 over 1, up 3 over 1, up 5 over 1. And that's our basic quadratic graph. Everything else is just some little change. So I can flip it over the x-axis when it's negative, and it can look like this. I can take the graph and I can shift it to the right 5. 1, 1, 2, 3, 4, 5. 1. And so now it looks like that. And I could take it and I can make it way thinner. So now all of a sudden I can go up 3 over 1 instead of up 1 over 1. And now that makes it skinnier. So I stretch it out tall. And so now what we're going to do is we're going to look at the equation and we're going to determine how is it going to affect our graph. Is it going to stretch it out? Is it going to move it to the right? Is it going to move it to the left? And we're going to use particular vocabulary to help us figure that out. So our original parent function, the original quadratic graph, is the y equals x squared. We compare all other quadratics to that. So we're going to look at what happens when we change our a value. So our a value usually is the number 1, because there's really an invisible 1 here. But if I make my a larger, what happens, so let's look here. We've got our original graph in black. Actually, so this is our original graph. The y equals x squared. When I change my graph to y equals 2x squared, so I change that a to get bigger, look at how it changes it. All of a sudden, we've got this red graph. And you see how it gets skinnier? Well, if I change it to y equals 4x squared, see, it gets even skinnier. And then if I change it to y equals 6x squared, it gets even skinnier. So as that a value becomes a bigger number, the graph becomes skinnier and skinnier. Because what ends up happening is this original point, here, let me grab a different color. This original point right here, all of a sudden starts shifting up. So this point is at 1 on the original graph, but when I get to the second graph, it all of a sudden pops up to 2. And this point all of a sudden with the 4 will pop up to 4. And so it's stretching that graph up, and when it stretches it up, it makes it thinner. It's kind of like with growth spurts in people. You notice that kids, they tend to get a little chubby around the cheeks right before a growth spurt. So they kind of get fat, and then all of a sudden they get tall, and it thins them out really quick. So as they grow up, it thins them out. And so a lot of times you'll find that that's why people want to be taller, is because it'll help thin them out. That's not what we're doing here, but we are thinning out our graph. We're not trying to thin out people, we're trying to thin out the graph by making our a value larger. We call this a vertical stretch because, again, we're stretching up. So the next thing I want to look at is what happens if we start at 1, our a gets smaller. So here's our original graph right here in black. And then we have the graph of 1/2 x squared. So now it's taking this point and it's dropping it down to 1/2. And so look, it makes that graph wider. And then what happens if we drop it down to 1/3? Well, it takes this point and it drops it down to 1/3. So then it becomes even wider. So as that fraction becomes smaller or closer and closer to 0, the graph gets wider. And we call that a vertical compression because it's like we're taking this point and we're pushing it down. We're compressing it down to almost nothing. Now, when I talk about a value getting smaller, I'm talking about it still being positive. So as it starts at 1 and then gets smaller. So as long as it's between 0 and 1, then that's going to get wider. But as soon as it gets less than 0, or aka negative, now we have a new pattern. So with the new pattern, if our a is negative, watch how that flips over. So we have a negative 1x squared. All of a sudden this point drops down on the other side of this line. And what is that line? That line is our x-axis. So now it's flipping our graph over the x-axis. And then, as we get the negative 2, it's making it thinner. The negative 4 makes it thinner. But the negative makes it flip. And we call that a reflection. Because technically a flip isn't a true mathematical term. The term would be reflection. So we flip it over the x-axis, which is really just reflecting over the x-axis. Okay, so now we've dealt with a. Now we're going to look at this k value out here. So the k value, it's the y value of our vertex. And k usually starts at 0. So when we look at our graph, our k value is 0. But then we move to, instead of plus 0, we're now going to plus 1. What happens to our graph? Instead of being here, it's now starting at 1. And so it's moving up 1. And so now when I take this 2, it means I'm taking it from here and I'm moving it up 2. And there's my graph. It has the same slope, but all it's doing is moving it up. So the k value moves it up. And we call that a vertical shift because we're shifting our graph or sliding it up vertically. And so that's our technical name, a vertical shift. Now, what happens if it gets smaller? So it's smaller in the negative version. So if I have a plus 0 here, and then all of a sudden I go to negative 1, this point drops down 1. And if it's a negative 2, then all of a sudden this point drops down 1, 2. If it's a negative 3, then the original point drops down 1, 2, 3. Which again is a vertical shift, but it's moving it down because it's going to shift in a negative direction. So negative 3 or negative 2 or negative 1. Now the h value starts at 0. And then notice that this plus 1 moves it in the negative direction. The negative direction for x. Why is that? Because of that minus here. So remember how that minus changes the sign for our vertex? So if this is a plus 1, it's really saying my vertex is at negative 1. And so that's why we're shifting in the negative direction, because that double negative occurred. And so we start seeing that down here, where this is really x minus negative 1, which means it shifts to the negative 1 direction. So if I have an x plus 2, that's really representing minus negative 2, which means we're shifting 2 units in the negative direction. And so this is our horizontal shift because it moves with our horizon. The horizon goes side to side when we look at the sunset, and that's what it does. It moves side to side. And then, of course, if it's negative, then we're just taking the raw value, and so then it's moving us to the right. Again, a horizontal shift. So let's summarize everything. Okay, this plus or minus, what does it do? Negative reflects over the x-axis. This is really our flip. Plus does nothing different. Now this A, this is telling us if we're going to get skinnier or if we're going to get fatter. So this A is our slope, and it is a vertical stretch if A is greater than 1. it's a vertical compression if A is between 0 and 1. So those fractions we were dealing with. Now this H is going to be our horizontal shift. It's our X value. It moves X side to side just like our X. So this is a horizontal shift. Which is right or left. And then this K is what moves us up and down, and that is a vertical shift. And so we use this to describe mathematically what is happening to our graph. And so these are our key terms. So we're going to use this as we go on. So here, this is our A value, it's 2. So that means that 2 is greater than 1. So we have a vertical stretch of 2. Here, it says -5, which means our original value is the opposite, +5. So this is our, I should color coordinate. So this is our green. So this is a horizontal shift of +5. So here we change sign. Make a little note to us. We change the sign. So this was really saying a horizontal shift of +5, which means we truly move our graph right 5. And then we come to our end value, which is our vertical shift. So this is a vertical shift of +3, which means we move up 3. And so this is how we describe what's truly happening to our graph. Okay, so let's look at our next one. Let's start with our negative in front. So the negative is reflect over x-axis. And then we move to our inside. We change the sign of that. So this is a horizontal shift of -1, and the horizontal is side to side, so this is left 1. And then at the end, this is our up and down, so this is our vertical shift of -9, which means we move down 9. Okay, next one. We've got a number in front. Since it's less than 1, this is a vertical compression of 1/2. And then we look at our inside, we change the sign, so this is our horizontal shift of +9, which means we move to the right 9. And then that's all we have. So that's all for our transformations on that. So we'll practice this in class, but this is pretty much the end of our chapter. There's a lot here, so I highly recommend taking some time to study.